Hi, my name is Romain and this is Yun, and today we're really excited to talk about our CHI'26 paper. So it is no surprise to anyone that AI has taken the world by storm in the recent years. We have seen AI help us build apps, edit images, or even describe the world around us. However, all these have something in common. They are symbolic. They reason with text. For instance, if I want to solve an equation, I can use an LLM like ChatGPT, and it would do it really well. That AI is taking my text as input, does some reasoning based on text, and outputs it back into text. Note that here, text is symbolic. And while symbols are very powerful, it is not the only way we interact with systems, or let alone the world. So what if the prompt was this?
Help me open this.
If the solution is to push down on this cap, by how much force should I be pushing down? 1 kilogram, 2 kilograms? And what does this even mean? This is where symbolic AI systems have a hard time conveying the correct knowledge to the user. In fact, in this paper, we're not interested in text-based AI. Instead, we ask ourselves what new form should these AI systems take? In other words, what if AI systems were not symbolic, but embodied? And by embodied, I mean things that you can feel through your body, such as touch, force, or even something that we usually refer as muscle memory in everyday life. Intuitive sequences of body movements or patterns that feel natural. So, we envision a new form of AI that uses your body as input by reasoning with nonverbal information and outputs it back to your body. Before we dive any further into this topic, let's take a look at this short teaser. Here we have a user that is cycling with our system. She's wearing a suit that has electrical muscle stimulation pads, like these ones. And this can actually send a small electrical impulse that causes involuntary movement as such. The suit also has inertial measuring units to track her body pose. In addition, she's wearing a smart glass that has a camera that captures what she sees and has a microphone to listen to what she says. As she walked up to the bus, she noticed an unfamiliar bike rack. Since she doesn't know how to use it, she prompts the system.
EMS, help me with this bike rack.
The system takes a picture through the smart glasses and uses it in conjunction with the user's prompt to help reason.
I'm going to move your right arm and hand.
And before doing anything, the system indicates which limbs are going to be moved. This is important because muscle stimulation can involuntarily move the user's body.
EMS, continue.
As the user confirms, the system moves the user's arm to reach for the handle. Every time that you see this symbol, the lightning symbol, there's a muscle stimulation, and the movement is involuntary. Have you guys noticed here that this is not a real bus? It is actually a training facility in Chicago to help people practice. This is because this task is so physical that reading instructions before or even watching a video is not helping. Let's rewind and take a closer look at what happened.
EMS, help me with this bike rack.
When she asks this prompt, her request gets fed into a Multimodal-AI based on language model, an LLM designed to generate detailed tutorial. As we mentioned earlier, LLM reason with text, so the output will be very descriptive. But muscle stimulation devices needs commands. Our system refines the LLM output to muscle stimulation commands through multiple stages. If we took a look at this example, the AI model picked a stimulation that would extend her elbow by 45 degrees to reach the rack. But in this case, her elbow is already fully extended. So we need to ensure that these commands follow proper biomechanical constraints by applying fixed rules. So our algorithms finds that the shoulder, this one, which is the parent joint of the elbow, can be used to perform a similar motion. And now we have a more refined movement in the form of muscle stimulation commands. Our system works from a single architecture code. We see that here.
Help me with this bike rack.
Help me spray.
Help me open this.
The same code adapts to different scenarios, and it provides the correct physical assistance. This is only possible because
Help me with this bike rack.
help me spray.
Help me open this. Help me open this window.
In this example, it not only takes contextual clues, but it understands it and adapts it.
But even with all these contextual clues, no AI is perfect in understanding and predicting the user. So we ran a user study to measure how people make sense of the generative muscle stimulation instructions in the ideal condition like this one here, but also, more importantly, with the task that we injected wrong instructions to try to understand how users recover from errors. So the tasks include take the pea out of the avocado with the avocado cutter, take the peel out of the peel bottle, pen with spray can, use the analog camera to take pictures, move the nail with nail sweeper, and open this unfamiliar window. Our study used pre-cached muscle stimulation instructions from our system, and the system did not read out the gestures beforehand. We went directly into the actuated movements. Now let me show you some example of participants' reactions. For instance, here we saw that even though muscle stimulation is not spatially precise, still, she could understand the muscle instructions to complete the task.
Pull and then, oh, okay, like moving it closer, and then I pull it up.
And in the cases that we purposely inject wrong gestures, like this example here, look at her hand. The system is shaking the one that does not have a spray can. Now let's see how she reacts to this erroneous movement. So she noticed the error and found her way around them.
Oh, it's doing it on this hand. Okay. So I need to shake the can.
Or if all failed, we saw that participants will rapidly reprompt the system to generate new instructions and keep exploring. To wrap up, we are going to share some takeaways and future directions that we can take. We engineer an embodied AI system that assists users with electrical muscle stimulation. But unlike prior muscle stimulation systems that require one dedicated program for each different interactions, instead, our system adapts itself based on the context. Like here, it generates the shake gesture only when the user is using paint, but not for cooking oil. The flexibility in our system can allow researchers to generate muscle stimulation movements for tasks that has never been explored in this type of haptic assistant before. Although we have this excitement, our work as the first paper that demonstrates a more embodied form of AI inherits the ethical concerns from both AI and physical assistance. We therefore design our system to let user control it with commands such as EMS stop and wait for user confirmation. On the other hand, we see a boom in AI assistant through other modalities as well. They work through audio, visual, or even tangible outputs. But we're more interested in the physical assistant that outputs with users' own gestures. And this brings us to a very interesting question. What is the limitation of machine-induced gestures? And what is the boundary of symbols such as text and visual-based assistants? We can potentially design better output modality for these AI assistants with the limitations in mind. Furthermore, we're not the only ones trying to make AI think in a nonverbal way. Robotic researchers have been trying to make robots smarter by building physical AI. Our work is similar, but instead of controlling the robots, we're making the user move or automate the body. Then we ask, what is the boundary of automation? What tasks can be externalized to a robot? And what's the value of embodiment? In fact, last year at CHI, we showed that after muscle stimulation demonstrates movement directly to the body, people learn even after they take off the electrodes. We therefore expect that body automation could actually lead to body learning. As the user gets muscle instructions to perform the task, they might be learning object mechanisms at the same time. For example, here.
Oh, I see.
This is a clip from our user study where this participant discovered the mechanism of an analog camera. We hope this will inspire future work on the development and evaluation of embodied AI. Thank you.